Good evening, everyone. I am Bhavin Jain, currently pursuing a BTech degree in civil engineering from IIT Bombay and currently a research intern at Maritime Research Center. I will explain about my project. So it is basically based on Kharagpur lake data. It was collected using a edge tech sub-bottom profiler. That works on the basic principle of sending sonar waves and then it performs imagery as well. So it performed on a depth from 10 meters to 15 meters range, and so because from the surface till 10 meters it was about water, and then near the below the surface it took about 5 meters of imagery. So I raw data at different frequencies, different sonar frequencies. So now the problem at that time to solve a sediment classification, and the problem still remains the same as well. But the previous work which was done, it was done with using mathematical models, and my aim was to using this using machine learning algorithms. So the what is the importance of my project is basically that currently sediment classification is very important. Uh, a sediment classification is needed to get past historical information about the geological area. It is also needed to it is also needed to it can also be used to analyze climate change, and it holds a lot of importance in conservation. And currently the methods are have evolved obviously, uh, from going to do basic sieving and plotting grain size to going methods such as diffraction, advanced image analysis, remote sensing. We have evolved to modern methods, but all of them have an issue which is a very heavy pre-processing and post-processing to get the final result, which which can eliminated by this machine learning thing, which is you can use support vector machines, CNNs, which are on the right side. So this is basically the lining of my project and why it's really important, because sediment classification is very important for the UD, and it's going to get more important in the upcoming thing, because industries, human activities, industrial activities, all of them affect sediment layers at a very level. So industrial activities lead to a larger runoffs, and then they can change the type of sediment. Over the years, we can see a very significant change in the type of sediment layers and their composition, which can be used to analyze how we are actually impacting the environment and the river and water bodies around us. So now, what was my methodology for the project is, so I was given for raw data from which was from sub-bottom profile as explained before. So first part was to analyze the data of what I exactly have. So after analyzing, so I figured out that I would be using data for majorly two purposes. One is to label the raw data, to label the each GSF files at different frequencies which have been given to obtain wide training, and another use of the data would be to obtain the features from of which a combination of features then can be used to train different types of models. Now, to label the raw data, two methods could be used: reflection coefficient method and relaxation time method, which were used previously by the research fellow which was working on the project. So, what is reflection coefficient? Reflection coefficient is basically the ratio of the transmitted energy upon incident energy, while relaxation time is, so basically the data which I've been given is, it is signal amplitude data. So now frequencies can be calculated from these signal amplitudes. So the change in frequency from one layer to another, and the change in depth, the ratio of that is basically relaxation time. So for different relaxation times or for different reflection coefficients, we can map the sediment types. So that is how I have planned to do the label of raw data, and that's what I'm doing currently. Then I will be extracting different features from it, almost 10 to 15 features. And I will train different types of models, which I'll be explaining further in my presentation. And after this, I'll just select the best model by calculating the accuracy, which test dataset. And so this I'll be splitting my raw dataset into three parts. One is training data, which will be majority of it. Then and the other part I'll be splitting into two: testing and validation data sets. So now for feature selection, I extracted various features such as mean amplitude, the variance of the amplitude, skewness of the amplitude, max wind, which can be seen here in the images. So all of these features are quite important. I also performed on how much important they are. I was researching on the PC, which is principal component analysis. It is an important thing in machine learning algorithms, which can tell us that how a factor is related to my core problem. So I was doing some experimentation with that to select the correct features. because this part is the one which is most important, because we have to select such features that, let's say, in the future, if I incorporate other types of data, not only the data from support and profiler, so the features should be such that they can also accommodate the values obtained from the data, and we can still get a reasonable, accurate output. Now, moving on to the types of models which can be implemented are, one is logistic regression, which is on the bottom side. On the top right, you can see a support vector machine, and on the left side, we have a neural network. So all of these models are currently, I'm working on the logistic regression one. So basically, a logistic regression model is a linear model where, let's say, if I have currently extracted 5 to 10 features, and I have to calculate a coefficient of bias for each feature. So currently, I'm working on the logistic regression model. I also plan to do a similar implementation support vector machine and CNNs after getting the features which are important, which I will be checking through logistic regression. So these are the models which can work, and I'll be selecting the one which will give me the most accurate result. Now, this project obviously holds a lot of applications. First of all, it eliminates the tedious task of pre-processing the data, obviously perform the task of sediment classification. And as I explained before, sediment classification is needed for a variety of important purposes. The future scope of the project can be to that we can incorporate other sources of data in it, such that we can help eliminate on-ground observations, such as remote sensing works purely on satellite and receivers. So in that time, we don't need to go on site and install a support profiler or SSH, which is sonar scan, and get the data. If we can automate this whole process, it can be really easy analyzing this data. One another aspect is to make models more accurate. So it can be used for more advanced features as they require very accurate results. Because the data, it would require obviously a lot of training, and maybe in the future we can reach a point where we have a very high accuracy, maybe above 95 or 98%, such that it can be used for high-end analysis. I hope I could convey everyone the importance of sediment classification and how learning is being incorporated in it. Already, a lot of projects have happened by someone by the Shanghai Institute, one in Mexico. I've analyzed many case studies, and I'm trying to extract something important from them and give my own input. So I would like to thank you all for listening to my presentation. Thank you.